Okay, for what we have in the first sheet of the handout packet, okay, we have looking at functions and their inverses, and we have in the case problem number 1, okay, we're looking at solving a function in terms of another variable, and we have for the first problem, okay, we have f is equal to 1/5 of the sum of g, h, we have taking away k, and in looking at solving for h, okay, again, the strategy is to isolate the variable h. So we have for this particular function, okay, what I can do is I can start out taking care of the fraction 1/5 upon multiplying both ends of the equation by 5 itself. And so in taking what we have now, okay, so you have 5 times f is equal to 5 times 1/5 of the quantity of g plus h minus k. And we have, again, on the right hand side, okay, the fraction will clear out. And so we have at this juncture, okay, we have 5f is equal to g plus h minus k. And in terms of getting h by itself, okay, I'm going to be looking at moving g over by subtracting, as well as k by adding. So we have taking away g, and also adding k to both sides. Okay. So we're going to have, in effect, okay, getting h by itself. Now we have 5f minus g plus k is equal to h, or in effect, okay, we have h is equal to 5f minus g plus k, and that will be the final result. Okay. Now, for what we have in the case of the second item, where we are given two functions, f of x and g of x, for both parts. And now, for what we have in part A, okay, we have a couple of functions, f of x and g of x. Now we have f of x and g of x, okay, are each going to be the reciprocal of 6x. So we have for f of x and g of x. We're now looking at composing together what we have between f and g of x. So we have for f composed with g of x. And I'm going to do a bit of color coding here to show you how the compositions will interact. Okay, so we have f of g of x. Now we have for g of x, okay, I have 1 over 6x. And I'm going to operate along the lines of f of x equal to 1 over 6 times the input. And for the input, set of x is going to be 1 over 6x. I have 1 over 6 times the input. Input we have at 1 over 6x. And for what we have in the follow through, okay, so you have 1 over 6 over 6x. And 6 over 6x becomes 1 over x, and we have 1 all over 1 over x. And if I take the division of a fraction and put it in terms of multiplying, okay, I have multiplying by the reciprocal, so we have for the composition, okay, this comes out to x. Now for the other composition, we're now looking at taking g composed with f of x. And for what we have for g of f of x, okay, you're going to have a bit of history to repeat. Okay, we know we have, this time around we have g of f of x, and again, f of x like g of x earlier. Okay, we have 1 over 6x. And then following through, okay, so you have 1 over 6 times the input, which will be 1 over 6x. And we have in terms of following through. Okay, so you got 1 all over it, and we have 6 over 6x. And we have 1 all over the reciprocal of x. And we have, with history repeating in the follow through, dividing by a fraction, same as multiplying by the fraction's reciprocal. Okay, we come out to x. And now, in terms of whether f and g are inverses of each other, the criterion for this will be that the compositions between the functions will both end up at x. Okay, so since f composed with g of x and g composed with f of x are both equal to x, we have f and g are indeed inverses of each other. Okay, now for what we have for part B, again we have again with our functions this time around, we have for f of x and g of x. Now f of x, we have equal to x plus 2, and we have with g of x is equal to x plus 2, and we have for the setup, okay, for f composed with g of x, so we're looking at f of g of x, so we have g of x, we have at x plus 2, and operating along the lines of f of the input is equal to the input plus 2, and it's going to follow that we have x plus 2, followed by the addition of 2, and x plus 2 is going to become x plus 4. Now for g of f of x, and we have g, in this case we have g of x plus 2. And I'm trying to maintain the consistency in terms of the color coding. So for what we're going to have in terms of the follow through, okay, so you have the input plus 2, and we have with this particular other composition, okay, we also end up at x plus 4. Okay, and this time around in terms of whether we have inverses or not. Since we had that the compositions wind up equal to x plus 4 as opposed to x, because neither composition is equal to x, f and g are not inverses of each other. Okay, so for, and again, to be inverses, the compositions have to be equal to x. All right, now in taking now what we have regarding, okay, what we have for number 3, we have for this setup, okay, so you have our function g, so we have g, or in this case g of x. Again, this is just a functional notation for what we otherwise say is going to be y, and we have assigned ordered pairs, whereupon we have 0, 4, 3, negative 2, yeah, 4, 0, and 5, negative 8. And we have with our function h of x, here our function h of x, okay, we have is equal to 6x minus 13. All right, and we have just for the setup, okay, and it says we have finding the following. Okay, so we have looking for the inverse function of g whenever x is set to 0. And let me mention something. Now, for the inverse function of g, okay, again, a one-to-one function and its inverse will have interchanging x and y coordinates. And with interchange, so we have 4, 0, negative 2, 3. Also have 0, 4, and negative 8, 5. And for what we have at this juncture, okay, it's going to follow that for the first part. Okay, we have for g of negative 1, whenever x is set to 0, when x is set to 0, okay, we have corresponding y value is equal to 4, and so we're going to have for the inverse function of g, whenever x is set to 0, okay, that is equal to 4. So it'll be the first answer that we have. Now, in looking at the inverse function of h of x, now we have h of x is equal to 6x minus 13. And for h of x, again, this is a functional notation for what we otherwise say is going to be y. And again, if we look at interchanging the x and the y, creating the initial pathway to getting to the inverse. So we have interchanging. So we have x is equal to 6y minus 13, and expressing what we have in terms of y after the interchange. So you can look at adding 13 to both ends. And for what we have now, we have x plus 13 is equal to 6y. Then we have with division by 6, so you have x plus 13 over 6 is equal to y. And for this value or expression y, this is going to become our inverse. So we have the inverse function of h of x is equal to x plus 13 all over 6. So that'll be the second answer in this three-part situation. And now again, a one-to-one function and its inverse will compose together at the assigned value x. And whenever x is set to any value, in this case 3, okay, again we have for the composition between the inverse and the one-to-one function. And the outcome here, last part, okay, ends up being at 3.